Power semiconductor shortage. The world is now dreaming of innovation. In order to realize eco-friendly policies, Net Zero 2050, and ESG management, we are facing a big change in the world, and power semiconductors are becoming a key point at the center of this change. Power semiconductors are used in various fields, such as electric vehicles, cranes, aircraft, sunlight, and servers. The potential for future developments is very high, and customer demand is increasing significantly today. Among them, power semiconductors are mainly used in electric vehicles. It is expanding its supply from the existing combustion engine cars to green cars, including electric cars. By 2035, Europe and Japan are aiming for a 100% transition. And by 2030, the United States is planning a transition of 50%. China is planning a transition of 40%, and Korea is planning to have a transition of 83%. To make these power semiconductors, above all, SiC Wafer are essential materials. Senic is making a leap forward as an SiC market leader to meet its global needs. Then, let's talk about SiC Wafer. SiC, a semiconductor compound consisting of silicon and carbon, belongs to the wide bandgap family of materials, and it is generally referred as silicon carbide, or SiC. SiC can utilize energy much more efficiently compared to the existing silicon materials when manufactured as semiconductors. Compared to silicon, SiC has 1/3 times lower resistance, 10 times higher voltage, and more than 2 times higher electronic density. It is also a material that can withstand high temperatures of up to 600 degrees Celsius, making semiconductors that can operate even in high-temperature environments. Recently, 150mm wafers have mainly been in the spotlight as main materials for power semiconductors. And Senic strives to provide high-quality 150mm SiC wafers to customers with advanced technology and systematic production process. Senic uses highly purified SiC powder for high-quality SiC production. And ingot is produced using the hot zone of self-production through PVT growth method. The SiC ingot is made by grinding the exterior and flat zone, then sawing the ingot using a wire, and polishing the surface to make a wafer. In addition, high-quality SiC wafers are produced by confirming the crystalline and surface quality of the wafer, from which impurities have been removed, through the CMP process and cleaning process in the clean room. And for the convenience of customers, if they want to reuse wafers that have undergone an epitaxial process, Senic is also conducting a reclaim process that removes the epitaxial layer and returns them to the bare wafer form. After 2 decades of research, Senic started in Cheonan, Korea in 2021. Senic has been the only company that owns the advanced manufacturing technology and process of 150mm wafers for power semiconductors in Korea, after developing 2-inch and 4-inch wafers. In the case of 200mm SiC wafers, we are aiming to produce them by 2024, and we are working to localize the 200mm ingot grower and crucible structure design through a joint facility development agreement. Senic has a total of 190 IPs, including overseas and domestic ones, and is continuously researching based on IP competitiveness. In addition, we've obtained ISO 9001, 14001, 14002 certificates, and strive to keep the standard of quality management and environmental management, as well as give trust to customers. Silicon Carbide Engineering Innovation Corporation, Senic. Through constant challenges and innovations, we will grow further as a global silicon carbide manufacturing innovator.